morning friends. Already we discussed about the energy band diagram for the material or the conductors. Right? In energy band diagram, the energy band containing the energy levels of the valence electron is known as the valence band. Just above of the valence band, the another band is present that is known as the conduction band. That is known as the conduction band. There is some gap between the valence band and conduction band that is known as the forbidden gap. Forbidden gap. The difference of energy between the upper level or the maximum energy level of valence band and minimum energy level of conduction band is known as band gap energy EG. Already this thing we discussed in earlier lecture: conduction valence band, conduction band, forbidden gap and band gap energy. Okay, the value of band gap energy or the size of forbidden gap is depends on the type of material. That means the distance between the atoms of the molecules in a material. The size of the forbidden gap and value of band gap energy depends. Now, our question is that they explain the conductor, insulator and semiconductor from energy band diagram. Or what is the energy band diagram for the conductor, insulator and also the semiconductor? We know that the conductivity of the material depends on the numbers of the free electron present. In insulator, the metal or the material does not have any free electron is act as an insulator. While some material like as the silicon and germanium has the characteristic is that at 0 Kelvin temperature there is the absence of the free electron is act as a perfectly insulator. As the temperature increases, so the covalent bonds are broken, free electrons are produced. As a result, its conductivity increases. So this type of the material is the semiconductor. Now we have to do the energy band diagram for the conductor, insulator and also the semiconductor. For that purpose, some basic concept: the difference between the minimum energy level of conduction band and maximum energy level of valence band is known as the energy band gap EG. That means the difference of energy between minimum energy level of conduction band and maximum energy level of valence band. That is known as the energy band gap EG. There is no energy level in this energy band gap, and such region is known as the forbidden gap. This region, that means whatever the empty region between the conduction band and valence band is known as forbidden gap. In forbidden gap, there is no energy level. Okay. Now, depending on the type of material, the forbidden may be small, large or the 0, and depending on this gap, there are the 3 types of material. Depending on the size of the forbidden gap, we can divide the material in 3 categories: conductor, insulator and semiconductor. Right? Now the size of the forbidden gap depends on type of material. Inside the type of material, the distance between the atoms of the molecules. If the distance between the atoms is less, so this material is act as a conductor. Right? Okay. Now the base of the depending on this gap, that means the size of the forbidden gap, the material is divided into the 3 categories. One is the conductor, that means the metal. In a metal, the forbidden gap is very small, or the forbidden gap is 0. That means the energy level of the conduction band and valence band are overlap each other. as shown in the figure. Now there is the valence band, there is the conduction band. If the forbidden gap is very small, that means the energy band gap is very small. So in this situation, what are the electrons inside the valence band easily cross the band gap energy of the forbidden gap and exist to the conduction band. As a result, the conduction of electricity takes place. This type of the material has the less resistivity and conductivity is high. Or in other words, in some material, the energy level of conduction band and valence band are overlap each other. There is no forbidden gap. Therefore, electron from the valence band easily enter to the conduction band. Therefore, the conduction of electricity takes place easily. Therefore, the conductivity of the material is very high and resistivity is very less. So, these two diagram of valence band and conduction band for the case of good conductor. Okay. From figure 1 and 2, one can have the metal, either the conduction band is partially filled and valence band is partially empty. Why the partially filled and partially empty? Because here the band gap energy is less, that means the size of the forbidden gap is less, therefore the electron from the valence band can easily enter to the conduction band. Therefore, what are the electrons going to the conduction band? Here, the space of this electron becomes the empty. Actually, that is known as the hole. It is known as the hole. Hole is also take the part for the conduction of electric charge or the electricity. And what are the electrons exist to the conduction band are responsible for the conduction of electricity. Now, from the figure 1 and 2, I have the metal, either the conduction band is partially filled and valence band is partially empty, or the conduction and valence band overlap. Here partially filled, conduction band partially empty, valence band, while in this figure, the both bands are overlap. When there is overlap, electron from the valence band can easily move into the conduction band. And when the valence band is partially empty, the electron from its lower energy can move to the higher energy, making the conduction possible. So in both cases, the electron from the valence band easily enter to the conduction band. Therefore, the resistance of such material is less and conductivity is high. Conductivity is high. Therefore, this material is act as a conductor. Right? So in short, the material which acts as a good conductor, for this material, the energy band diagram are like this way, the forbidden gap is very less, or the both band overlap, so the conduction band and valence band are overlap each other. Therefore, the electron from the valence band easily enter to the conduction band. So as a result, the resistance of such material is less and conductivity is very high. Clear this? Okay. After that, the second is the insulator. If the material is insulator, in this case, the energy band gap is very large. That means the size of the forbidden gap is very large. So this type of the material, all the valence electrons are bound in valence band. That is the valence band. No electron has the energy to cross this forbidden gap. Therefore, no any electron can enter to the conduction band. Therefore, the resistivity of this material is very high and conductivity is less. Again, the material which has the very large forbidden gap, or the energy band gap is more than, or the energy band gap is more than 3 electron volt. The electron from the valence band can't move to the conduction band. Therefore, the conduction of electric charge is zero. Therefore, there is no conductivity take place. Again, if the distance between the valence band and conduction band is very large, means the energy gap is greater than 3 electron volt. There is no electron in conduction band, as well as rising the temperature. Electrons cannot move from valence band to the conduction band. Here the band gap energy is very large, 3 electron volt. As we increase the temperature of the material, no electron from the valence band can cross this forbidden gap and enter to the valence conduction band. So the such material does not carry the electricity, and thus such material is called as an insulator. So in short, in case of a conductor, the forbidden gap is very small, or the conduction band and valence band are overlap each other. While in insulator, what's happened? The distance between the valence band and conduction band is very large. The band gap energy is more than 3 electron volt. So the no electron from the valence band can cross this forbidden gap to enter the conduction band. Therefore, the conductivity of this type of the material is very less. As we increase the temperature, rise the temperature, the electron from the valence band has the no energy to cross this forbidden gap. Therefore, this material is act as an insulator. Act as an insulator. Clear this? So there is the two type of the material, conductor and insulator. Now we start our discussion about the semiconductor. Now in semiconductor, already we know that the silicon and germanium behave as a semiconductor. Silicon and germanium are the tetravalent. It has the 4 valence electron. But in semiconductor, like as the silicon and germanium, this 4 valence electron form the 4 covalent bond with its 4 neighboring other silicon or the germanium atoms. That means at 0 Kelvin temperature, in silicon or the germanium crystal, the free electrons are 0. Therefore, the silicon and germanium is act as a perfect insulator at 0 Kelvin temperature. As the temperature increases, the thermal oscillation of silicon and germanium take place. As a result, the some covalent bonds are broken. Therefore, the electron becomes the prey. And this electron can cross the forbidden gap and enter to the conduction bed. So this way, the conduction of electricity takes place in some semiconductor. So in short, in semiconductor, at 0 Kelvin temperature, act as a perfect insulator. As the temperature increases, its conductivity is also going to increase. While in insulator, forbidden gap is very large, more than 3 electron volt. Therefore, no any electron can cross the forbidden gap and enter to the conduction band. Right? Okay. For semiconductor, the material has the energy gap less than 3 electron volt. That means the Ag is 3 electron volt. The region between the valence band and conduction band is small. So, at room temperature, the some electron from the valence band can acquire the energy to cross the energy gap and enter to the conduction band. We know that the vibrational kinetic energy half m square is equal to 3 by 2 kb into. At 0 Kelvin temperature, all the electrons are not free. All electrons are bound in valence band. But as the temperature increases, that means at room temperature, the silicon and germanium atoms possesses the some vibrational kinetic energy. So as a result, the some covalent bonds are broken and electron becomes the free, and this free electron get the enough energy to cross this band, forbidden gap, and enter to the conduction bed at room temperature. This electron can move in the conduction band, and therefore the conduction of the charge takes place, and such material is known as the semiconductor. Again, the material in which the forbidden gap, that means the gap or the distance between the valence band and conduction band, is small, and the band gap energy is less than 3 electron volt. Right? So at 0 Kelvin temperature, all the electrons in valence band are bound. As the temperature increases, so covalent bonds are broken and electron becomes the free, and this free electron acquires the enough energy to cross the energy gap and enter the conduction band. This electron can move in the conduction band, therefore the conduction of the charge takes place. So such material is known as the semiconductor. Energy gap in semiconductor is less than 3 electron volt. Here the semiconductors are prepared from the two types of the materials, silicon and germanium. For silicon, the value of band gap energy is 1.1 electron volt. And the semiconductor of germanium, the value of energy band gap is 0.7 electron volt. Keep in mind these two values for germanium and silicon semiconductor. The semiconductor of silicon, the band gap energy is 1.1 electron volt, and germanium is 0.7 electron volt. Clear this? So this is the difference of the energy band diagram for the conductor, insulator and semiconductor.